Welcome everyone to the panel discussion about the future of healthcare. Specifically, we're looking at the near future, the somewhat near future to 2050. And I'm going to give a short introduction of myself, the panelists, and then I'll give some general announcements. I myself am the original founder of FruitPunch AI, also started in Eindhoven in the beginning, and now I'm working on creating this community to be global, as a global AI for good community, teaching people how to apply AI with challenge-based learning everywhere. Joining us are, you might have already noticed that Marlies is not here. Replacing her, we have Smriti, who you've already might have already seen. So for the people joining later, I'll start with her introduction. So she's an undergraduate student studying at the Manipal Institute of Technology in India. She's very passionate about natural language processing and artificial intelligence to create sustainable solutions for the challenges society faces today. And she's done some cutting-edge research projects for anxiety detection, sexism detection, and threat detection. And she's also won multiple very prestigious awards, amongst which the Google Hashcode. Now, Hildo Lamb, so Smriti is from the mental health domain. Hildo Lamb is a professor of radiology and director of the cardiovascular imaging group at the Leiden University Medical Center. And his clinical focus is on cardiovascular and thoracic cardiology, radiology. Currently on diseases related to congenital heart disease and obesity and diabetes. He's also the chair of the scientific committee of the Department of Radiology at the Leiden University Medical Center. And he is the founder of the Radiology News Network, which is a podcast that you can also find on Spotify. So I already really like to listen to these when I'm on my bike. I very much recommend it. Then we have Nicky Hekster. Of course, you've seen him in the past presentation. I see that he at the moment might have dropped out. He'll be back with us shortly. He's worked at IBM for quite a long time, and now he's in charge of the European business development around IBM Watson Health. And he's an expert in AI applied in the entire ecosystem of healthcare and life sciences. And he's also executive professor at the TIAS School for Business and Society, where he's responsible for the track of business analytics and artificial intelligence. His original background is in mathematics and physics, with a PhD from the University of Amsterdam. So some very impressive people in a lot of an uncountable amount of committees that I'm not all going to name. So we'll keep it with the instructions, we'll keep it there. Some general announcements are, please state your questions in the Q&A. You can find them on the right above the chat box, because this is a very interesting moment to, get some more time for these questions that you want to ask. And I'll have some, I'll go into the questions that I have as well. So Marlies could not be here. And after this, there will be the closing ceremony. So now on to the panelists. The first question I want to ask you, because I already gave the factual introduction, of course, is from each of you, what your vision of healthcare is, what it will look like in 2050. What are, and maybe specifically in your domain, what do you think the state of the art will be in 2050? And it's an interesting question. So you have to project it kind of 29 years into the future. And so I'm going to ask it first to Nicky, because I see him nodding already.
Yeah. I must say that that's very difficult. But what I see now as an extrapolation of all the technology developments is, for instance, that of course AI will stay here, and we will have much more and better and bigger AI systems to work on AI applications. And one of the computer technologies that's going to help us is quantum computing. Because I see that a lot of companies, including my own, but also Microsoft and Google and Rigetti, and there are many more, are aiming at commercializing quantum. And we really need this, because now today we have graphical processing units in combination with CPUs, that are consuming a lot of power when working on large neural. But quantum computers can take part of that work or can digest that kind of work. But also they can simulate things much more faster, but also much more precise aspects. And you know about qubits and quantum volume that will go up in the near future. So in the end, I think that also we will have a digital twin, which is a very interesting concept as a human being. Because today, for plants and maybe drilling platforms in oil, we create digital twins to simulate things that are okay or can go wrong. And why not do this for human beings? Because our body is a systemic entity. So we have a heart, we have lungs, we have all kinds of parts that work together, and it's very difficult to make those are coupled differential equations, of course. And with a quantum computer, you can do these calculations within minutes. So the effect of taking a drug or maybe a vaccination. So this is one thing. So and also protein folding. There are other applications make it much more personalized. And another thing that I see that we will use is like virtual reality or augmented reality. So, those tools are now already being used in mental health care, but also in the regular care by surgeons sometimes. So I think there are more, but these two things, and we need 5G networks, 6G networks, of course, to access all this. But I think that in 30 years from now, we will all have it. If you look back 30 years, what we then had, we already had the mobile phone, and the internet was coming up, the social media. There will always be inventions we cannot think of now that will be there in 30 years of now. So this is my humble extrapolation of what is happening now, but it's a very interesting question indeed.
Yeah, it's extremely difficult to answer, but I think you gave a very good answer because just from my limited knowledge, of course, of this field, because what I see happening now with digital twins is very interesting, and but we'll go into this in one of the later questions as well. I think maybe the hardest part here will be trying to get all the data that you need in one place, right? Because it's now so divided.
Yeah, but that also will. You're perfectly right, And we are now talking about federated machine learning and all kinds of technologies, data trains, and we'll get around that. That will be solved. But you're right. If there's a quantum computer somewhere in the cloud, you need a fast network or maybe networks between those quantum computers, to do the job. But in 30 years from now, we have tackled that.
Yeah. All right. So I'm gonna the same question from to Hildo. Where do you think that just generally the field of healthcare will be in 2050, and specifically the advances in your domain?
Yeah, thank you very much to have the opportunity to be present here virtually, hopefully live next time. I'm also in the board of the Radiology Society in the Netherlands, and we have recently developed a vision for the future. So that's quite easy for me to comment on that. Of course, for us, it's also very hard to predict such a long time ahead. But what we are experiencing now is that, of course, AI is quite important, but only is at the start. So there are a few small steps we are making in the real day-to-day clinical application for especially pattern recognition and in quantification of abnormalities, but that's only very, very small application. We have lots of challenges to implement it in the clinical workflow in such a way that we save time. And that is the problem now, because if we use AI, we take 3 times longer to do the reporting of a CT, because the license is expired, the software is crashing, whatever, all kinds of problems. So I hope by the time of 2050, we have indeed quantum computers that solve all the computational problems. So that's an important thing. But for our work, and I think also for other people working with images like a pathologist or radiotherapy or nuclear medicine, or there are all kinds of medical specialties involved in that, that we are shifting actually. And what we are doing now is mainly based on making a diagnosis. So we look at the CT scan or an MRI and we make a conclusion and a report, and we send that to the clinician, and then the therapy is started. That's how it works now. But we think that many of those tasks can be performed by the computer. Especially image analysis is really working great. I work in the cardiovascular field, and we've been working on contour detection of the heart for 20 never worked until suddenly AI appeared and the computers were powerful enough. So now it really starts to work. So that's very promising. But then the question, of course, is, well, do we need a radiologist? And we think we still need it. And our adagium now is that the radiologist will disappear, but the radiologist with AI will be the navigator of healthcare. So we think our role will shift more to guiding the whole diagnostic process, managing the patient, more contact with the patient. And actually, that is what we call our role as consultant. So we have to communicate more with the clinicians, with the patient, and be involved in all the decisions for the next step. Biopsy, what to do next, what therapy, how to monitor the therapy. And another important branch that is now a small portion of our work is that we also perform treatment, especially in interventional radiology. And that branch is already also moving a lot to clinical work, to more outpatient clinics where we have our own patients, where we do more and more therapy together with other specialties like vascular surgery or other medical specialties. But we think also that will be a more and more important part of our work. So, and because all of that, we have to be in the driver's seat as innovator. So that's why a lot of radiologists are now involved in innovations. We have a lot of collaborations with industry in public-private partnerships. So that's actually the direction we think we will go, because for us, it takes a lot of time to read all these CTs. Yeah. And that's actually even boring at some time. And the end result is making a text report, which is very stupid. We already do that for 100 years since Röntgen invented the X-ray. So what we are doing now is developing more interactive reports with image links and hypertext links and annotations on the pictures of the CT itself, instead of just the text report.
Yeah, that's one step.
Yeah, this is exactly what Nicky was talking about in his presentation as well, that just kind of the lag in technology towards the healthcare sector. It's kind of perplexing to me that you say that at the moment it can take longer to actually use AI. I would have always expected that it would shorten the time, but it would, right?
Yeah, the main reason for that is that you have in our hospital in Leiden, I think we have even more than 30 different vendors, and they all have their own software solution, and they all work on a different software platform. So it's terrible. So when we do an analysis of the lung, we have to start a software package specifically for lung noduli, and another package for pneumonia, and another package for COVID-19 or whatever. And the user interface is always different. And then indeed it turns out that the license is expired. So it's fully non-integrated in our workflow.
Yeah, so we should see in the future, I hope, pipelines will solve that, because, and I also know that the budgets that you need for AI, it's terrible at the moment, because nobody is convinced that it really works. But I see a clear technology. I see a clear advantage in terms of time, in terms of preciseness. But I want to ask you something, Hildo. Do you think that telemedicine and video consulting and all things that we can do at a distance, maybe even sensors in a human, will influence your domain in the future?
Yeah, for the direct effect on the radiology and teleradiology is maybe small, because I think it started some more 10 years ago that people were discovering this opportunity for reading of scans very far away in Australia at night, and the other way here for Australia. But it doesn't work out because it's not all about the image. And that is what people forget. They always think radiology is just looking at the picture and give a report, but that's not what we do. We integrate the whole clinical information, the complaints of the patient, the lab work, the pathology, the whole story and the history of the patient. And if you just send an image to Australia, then they don't know anything about the patient. So that particular thing is difficult. But what we are trying to establish now is because radiology is becoming so complex, we have to specialize and even sub specialize, because it is too complicated. Therefore you have a need for regional collaboration, because in one hospital you do not have enough cases. So for example, for the Netherlands, we can say, well, send all the difficult congenital cardiac cases to one center, do all the difficult neurological cases to another center, and then do a sort of teleradiology like that. And the last thing you said is quite interesting, because I know indeed that there are now some sort of bullets you can inject in the liver, for example, or in tumors that measure all kinds of parameters like pH or saturation or CO2 levels or whatever. And that is really, really interesting if you can detect that with your mobile phone with a device and send the data to the the hospital.
Even before things are going to happen, you know. So it gives you.
And actually, that's what people always say. That's another reason why we don't need you anymore, because we don't have to perform CTs. But then we always say, but now we are overloaded with work, and the number of radiologists cannot increase. So we are very, very happy if there are innovations that reduce the number of CTs, because we cannot handle it.
Yeah, I love. I was looking at the research that you're doing at Leiden University Medical Center, and I love this. You know, this embracing of technology. Really, even though there is this stereotype of radiologists. I don't know, like not wanting to know anything about this technology that is, so to say, would come there to replace them. But before we move on, I want to ask the same question to Smriti, and then I already have a bunch of other questions that came up while you guys were talking. So the same question to you, within mental health and the other fields that you specialized in, where do you see this field being in 2050?
Yeah, can you hear me? Am I audible?
Okay. Yes.
Okay, so like everyone already said, right, 2050 is a really long time, and I think that we can actually complete a lot of tasks in that span. Coming to specifically healthcare, I feel like precision medicine will help us personalize the experience of a lot of patients at that time, and that will help a lot, especially in the mental health spectrum, because mental health is something that's very personal, right? There are no rules or there are no boundaries as such. So the more accessible technology becomes with an increase in data everywhere and with an increase in the computing power in general, I feel like we'll be able to cater to the very specific needs of mental health for patients all over the world. So if you look at an example, we already have conversational agents like Visa and Wobot that have come up for cognitive behavioral therapy, right? And this is right now, this is in 2021. So these bots are trained to help patients or help people feel better, combat depressive instincts and like negative thoughts, right? On the other hand, we have bots that are capable of detecting suicidal intent and reporting them to international suicidal helplines and stuff like that, right? So in the future, you can only see that getting better and hopefully being scaled accordingly, right? Like we want it to be reachable to everybody. And if this is what is happening now, we can probably come to a point where, the such conversational agents or even intelligent systems of other kinds are able to listen in on maybe therapeutical sessions and, provide their input to the professional therapists, like Hildo said, it's not about eliminating the therapists at all, but instead using a combination of both, like therapists and the AI systems, to develop the best possible experience for the end user.
Yeah.
Yeah, and do you think that what Nicky was talking about, that was the end of your vision, right? I didn't mean to interrupt.
Yeah.
So do you think that what Nicky mentioned, these digital twins, which are what I've read about, digital twins in healthcare, are at least still very much about, just physical health. Do you think that we at some point will also be able to model the brain without having to have artificial general intelligence, aka is it possible to make like simplified models for mental diseases, or do we straight away have to understand exactly how consciousness works?
Well, I think depending on the specialists that are looking at it, we are already aware of which areas of the brain are able to trigger certain emotional stimuli. And like I said, it's only 2021, right? So why not? I mean, I definitely think it's possible to incorporate that in mental health. But the question that remains is to what extent? Maybe in 30 years, we see some of it happening in mental health, but maybe not all of it, right? I mean, it could just be the start. Like basically what AI is for us today, AI in mental health care, maybe 30 years later, we'll be sitting and talking about how this is the start of using digital twins in mental health care.
Yeah, exactly.
And I want to, this is a very good remark. And I think that in mental health care, you can do a lot with other things, like your speech. I mean, we have a sensor here called your mouth that is producing sound. And with that, we have done in IBM research a test with people younger people between 18 and 40 years that were suffering from psychosis. And what we did, we digitized the conversation with their psychologist, and we could predict from the wording and the word length and the sentence length, so not even the tonality, but only the language, when they would fall into a psychosis again, So think of a future where you talk to your phone and you take into account your tonality, so the tone and the words you are using. So that could be a tool that could predict things and protect you against weird behavior. So this is also a thing. So then so this sensor here, our mouth, is of course something that is being managed by our brains, of course. So without going into the brain itself, all things we do. That can be measured, of course, and this is, I think that this kind of technology also will be manifest in the future. It's a very interesting thing that we did.
Just a question about that. Yeah. What about the implementation of such a project at scale? Would that be okay? Would there be like privacy issues or ethical issues that come up if you talk about implementing this kind of system to scale?
Sure. If you want to, I just gave a presentation about ethics, but of course you need to take this into account, and you need to consent if your treatment by your psychologist is can be used to train these systems, because we need that data, of course. But in this case, we had a very small set of patients that were willing to do this, and but we were. Surprised that it had almost a 99% exact prediction. Even if the n is small, you can do a lot. So it means that this is a very important sensor, which we should use in the future.
And just to kind of continue on that, but also take Hildo into the conversation. when you know, when we're collecting all data from all these different sources, right? So we have basically people their own phones, but then also the images that are taken in hospitals. We were just talking about, you know, creating this one pipeline, or this one method through which we start to have to combine data. What do we need, Hildo, to get there? Do we need and also Nicky and the rest, of course, do we need like a company like Google to kind of just come into the market, have the monopoly, or IBM, and come into the market and kind of take over this space? Or do we need, you know, some kind of you know, I don't know how this would work from a governmental standpoint. Like, who is going to create this system?
Yeah, one of the big problems currently is, of course, the privacy law. And that is a really limitation for AI developments or cloud solutions, because it's not allowed to share the data, and you might share the data after permission of the patient or who else is involved, but only if it's anonymous. So you cannot add new data to it later. So that is a huge problem. And actually, the consensus is that all the data should stay inside the institution where the data was gathered. And you can have remote access, but the data should stay local. But I've also heard about creative solutions with the blockchain technology, where you give the patient sort of control on their own data, where it's stored centrally somewhere else. But it's a huge problem. Also in COVID period, we experienced that. We wanted to build a huge national database for COVID clinical data, lab data, image data from CT and chest X-ray. But actually, we could not start that. All the technology was there, but the privacy law was the big problem. So that's something that has to be solved.
Yeah, exactly. And how do we solve this? Is this a matter of just completely overhauling the regulations? Because it seems like the EU, also from the previous presentations amongst Klaus, it seems like the EU is taking a tighter grip on these regulations, right?
Yeah, it's important that we try to solve it ourselves as citizens of the Netherlands, because I think it's not so nice if Google gets all our data, and that insurance companies can buy that information from Google and then base their ratings for the insurance on that. So that's dangerous. But I think in the end, the patient, in this case, in the healthcare domain, is the owner of the data. So I think indeed some sort of solution like a blockchain where the patient gives active consent of usage of their data is important. But that's for the clinical part. For the research, we are now also in negotiation with the Ministry of Health to figure out how we can make a system like a donor organ registration, but then data donor registration, where you have a sort of central database where you can check if a patient gave consent to use their data. That will take, of course, many, many years. It's really complex. But I think in the end, that is the best solution, that you register who allows you to use their data and who not.
Yeah. And because now we're talking about in the Netherlands, of course, and this is where most of our expertise here is as well. But Nicky, you're also responsible for the rest of Europe for IBM Watson Health, and Smriti, you're all the way at the other end of the earth.
Yeah, go ahead.
Well, and one of the questions that we have here that I think kind of fits perfectly in here is how, like, this, we might be able to solve this here in the Netherlands, but shouldn't we go for more a global approach? And how does this work with the diversity in ethnicities and ways of life and different policies around the globe?
Yeah, but even around the globe. I mean, we are all already working on the EU level, because there's a lot of activity in AI and ethical use of data, and that has not been settled yet because there's a lot of discussion. And in my presentation, I just pointed out that ethics, it depends on the country, it depends on the people, depends on the region even, or maybe a doctor, you know, that has a different view on ethical use of data or treatments. So that will be a tough discussion, but the discussion will not go away. I mean, in 30 years from now, you were asking that, how will the world look like? We will still have to deal with privacy and security. There is this book called The Circle. Have you ever read that or seen the movie with Emma Watson featuring, you know, her, of Harry Potter? But The Circle is a company like Google, a Google-like company, and this was written long before we were discussing these kind of things, that knows everything about you. And basically, the basic theme is, can we do without privacy and without intimacy? You know, and the answer is no, we cannot do that. So it's something baked into our human beings, and that's why we need to deal with that. And you're right when you're saying every country does this differently. Yeah, Germany is much stricter, you know. France has a different option, and we were starting with this discussion. Should we do all these AI things on our own, or should we let in big tech like Microsoft, Google, IBM, whatever? I think that I think that these discussions will faint in the future. But you know, what I see now is everything is starting. We are not at the level of science fiction like artificial general intelligence. So we are starting with small projects at the hospitals, at some healthcare institutions. And this is good. But in the end, you need, and they have the data. And that's what's lacking with IBM and all these other companies. They don't have the clinical data because they don't have a hospital. You know, they don't own that. So in the end, you need to collaborate to work on this, but because what they have is very good tooling, and Google, Microsoft, IBM, all of them have very good tools and clouds where you can run this on. And then you come into the discussion of privacy and security, but that can be taken care of. They are all compliant with HIPAA, with GDPR, so everybody does that. But you know, in the end, you want to use this in your workflow, and it should be compliant with the way people, our doctors, are working, you know, and also if it's developed by maybe an iOS or an iOS, some PhD student, and he goes away, what happens to the support of this application? So but if you go to a big tech, then there's a roadmap, there's a portfolio of products, you know, you have support, you have data scientists, you don't have to rely on your own or go to the Faculty of Informatics. So we need to find each other, you know, and this is a very good question, and I have discussions of this kind many times. You know, what do we need to do? And people are hesitating because maybe they are used to Google that takes everything they can grab from their users of their free products. And you know, if something for free, then you are the product. That's the business model of Google. But they also have measures that can be taken, and these others do that too. So you need to have a discussion with them, you know, and find each other some way in between. But we need to get rid of all these different vendors that are doing their things on their own. There's no standardization. And what you said, Hildo, is perfectly true, that you want to build a pipeline, but it's depending on all kinds of licenses and integration interfaces. But that will vanish in the future, I guess.
Yeah, and Smriti, is this very different in India, or is it the same kind of spaghetti of?
In India, yeah, okay. So it's a different kind of healthcare. You know, it's a different kind of healthcare. I mean, there are many more people like China. The doctors, with all respect, don't have the level of the Western Europe oncologists or even in other countries. But you know, the nice thing is of AI systems, like one for oncology, for instance, we have, that it recycles the knowledge of the best doctors around the world, you know, and in our case, from Memorial Sloan Kettering in New York. But so you have the knowledge at your disposal, be it an AI system that you can mistrust because maybe you want to do it differently. But anyway, it's a very nice way to capture all the knowledge that is inside Hildo's head and inside Paul Algra and all these radiologists, you know, that we can reuse it, that we can really reuse it. And we can make a business model out of that even, you know, together with IBM or with a hospital, because you have the knowledge, you trained it, and we sell it, for instance, you know, we have the means to sell things, and have a support team around that. And that's not something you will find in a university medical center. You know, so
it's pretty much the same here as well. You know, I mean, we have the same kind of trade-off between privacy and build licenses and open source. But I feel like here one of the advantages that we have, like you correctly said, is the size of our population, right? So the number of people willing to give their data for a greater good just becomes larger because the number of people itself is larger, right? So when you look at Reddit, like for example, right, because that's a great place where we have separate subreddits for every country, right? If you just simply run a comparison between the amount of data that you will find on a channel on Reddit that's based in America or Europe versus the content you'll find in India, it's a lot more in India because the number of people are more in India. So stuff like that comes into picture, right? And one way to solve the data problem, I would suppose, like the transition between like privacy and the need for data, I feel like once we can anonymize data properly, we might be able to open source it. Because I mean, depending on where the data was taken from originally, obviously, because once you anonymize data, it no longer belongs to a certain person, right? Their privacy is no longer being compromised. So,
but Hildo, Hildo had a very important objection to this, I think, and that is that the moment that you anonymize, you can also not go towards this, digital twin model where you integrate a lot of different sources because the effect of a certain disease, and Smriti also said the effect of a certain medication differs so much from person to person, and that greatly depends on all the other stuff that's maybe not wrong with them, but that's unique to them, right? So, Hildo, how do you look at that? This is a big problem, right? The anonymization itself. So.
Yeah, and in the end, of course, you would like to have a system like the pseudonymization, where you can still connect new data to existing data, but then you need an institution that is reliable and independent and provides the key between the source and the database. So that's it can be established, of course, and also the confirmation by the patient. Another aspect is also that's obvious that the quality of the input data for training of the model has to be very high. And I think that's a nice opportunity for Europe, maybe especially the Netherlands and Germany and countries around us, because the numbers we have are, of course, very small compared to India and China. We're a very small country, but the quality of the data is extremely high. So the training of the models can be performed quite well. But there we have another issue. That what we would like to do is that we train the AI on day-to-day, case by case. Every day, every case we do, we learn and train the system. But that's not allowed, because there you also need approval of the patient, that the computer is looking at the pictures, looking at your text that you're dictating for the report, looking in all the text and the history. But that's actually a pity, because there we are missing opportunities, because if we would do that day-to-day basis and all the cases are feeding the system and retraining, then in 5 to 10 years we have a brilliant solution for all these problems. But so that's a huge limitation, actually.
I think we're running towards the end of our time, so I'm just announcing it now, because I don't know if we can actually continue or we will be cut off. But it says please rejoin the panel discussion by clicking on the main stage. We're still in the panel discussion. I don't know if something has changed.
Let me make one remark in addition to this.
Let's do some closing statements.
Political side of things, and I think a country in Estonia, I also did a project there, but Estonia has a government that has decided to use blockchain. You already mentioned, Hildo. You can vote by blockchain, everything, but also the data, the patient, the genetical data, which will also the genomics will also be taken into account in the future, because if we have quantum computers, we can do much more things. But people are consenting, of course, and its privacy and security is observed. But most of the people that are willing to donate their data third parties can work with it, under strict contracts, of course. But Estonia is very much advanced in these views, how it should move forward and to the benefit of their healthiness of their people. So this is a very nice example of how it should go. And they have 5 million or 6 million inhabitants. So it's like a region in the Netherlands, or a couple of provinces. But and India, Smriti, you are right. This is an opportunity for everybody, because so much data, but it should be governed and be treated in a good way. But okay, this is the last thing I wanted to say about this.
Yeah. So it's a mindset thing as well. Yeah. What did you say?
And we need a digital ministry of digital affairs. I'm pro because we are lacking behind. See what's happening. But okay, now I'm not going to go into.
That's a great idea.
Yeah. We need a ministry of digital affairs, really.
Yeah. Maybe even a digital minister.
And how to connect. Yeah.
Maybe even a computer simulated minister that will make better decisions.
Yeah.
I watched a show about that. It did not.
And yeah, so maybe some an interesting thing to kind of start wrapping up with is the last one, which is the where does the responsibility lay? We haven't really gotten into that, and recently we're doing some ethics, some collaborations on ethics with the Technical University of Eindhoven, and some very interesting topics came up there, where they basically said, well, when we're applying these algorithms that you saw at the beginning of today's event in hospitals with FruitPunch AI, the question becomes, who is responsible if it goes wrong, right? Is it the radiologist that carries the full responsibility? Is it, or is it the people that made the algorithm? So first, I want to hear from Hildo what you think about this. Oh, but I saw Smriti. Go first, and then Hildo.
That's fine. Yeah. No, I was just going to say that in my opinion, I think the developers have a little bit more responsibility. Of course, it depends from case to case based on where things went wrong and at what point things went wrong. But I think that as developers, right, we have to take complete accountability for the systems that we build, right? And I know that's a very controversial thing to say.
Yeah,
that's a very controversial thing to say. But I'm not saying it's going to be 100% the developer's fault, right? But I'm saying that the developers can't just be like, okay, well, we deployed it. This is not in our hands anymore. I feel like that should never be the case. At least the developers should always be willing to look into what, take some amount of responsibility for it and say that, this is what we can do to help. Because, at the end of the day, the systems, the artificially intelligent systems that are coming up are largely possible because of the contributions of the developers, right? And with great power to develop these systems comes great responsibility. So that's my 2 cents on the matter.
Yeah. Thank you, Uncle Ben. He's Ben, right? And Hildo, what do you think about this?
Yeah, I always imagine that I'm a patient and that my diagnosis is made only by the computer, and then I would not be so happy. So at the current state of technology, I still think that the medical specialist or the GP or whoever involved is the end responsible for the diagnosis and the decision. Maybe in the future it will change. There are new models like what they use in automotive industry, where you have self-driving cars. You have a collision of 2 self-driving cars, who has to pay? And there are also solutions for that. So they are setting up a sort of global insurance fund paid by a percentage of the profit of the sale of the car. And then when there is a collision, it's nobody's blame, but it's just paid from this general insurance. And maybe in healthcare, they can develop the same sort of system that if the computer makes a mistake, it can happen, of course, and then you have a sort of general fund to deal with that.
But and as human beings, I feel that very often there's also kind of this want to be able to hold a human being accountable, in the sense of like, if it goes wrong, people want to punish somebody, so what do you think about, like, should we just kind of start forgetting about that then, or because that's not the case with this global fund that you mentioned?
In the end, of course, still a human is responsible for the whole chain. I hope, at least, in 30 years. So yeah, somebody has to be responsible for the quality of the system. But the question is, who is that? Is that the technician or the engineer or a medical doctor or not? Yeah, that's open for innovation. But in the end, a human is or organization is responsible for that.
Yeah. And Nicky, what do you think about this?
Yeah, I think first of all, if it could be sensors in the future, implanted in human beings that are self-steering or alarming. But today, without all those AI and machines, we are still making mistakes. I mean, doctors make mistakes. There are false alarms in the ICU. So this is just happening. But I think with AI, I showed in my presentation a chart where you see the complete team of developers or developing AI, which is the data scientist, the data engineer, the medical expert, the medical ethical expert, and so forth. So I think that they have a task to discuss this amongst each other to push the limits of an AI application. And still then, it's only one tiny part of a big chain of treatments of patients, because it's not... There's no AI application that does it from A to Z, for the patient, because you have a nurse, you have maybe a psychologist that does something else, or it's even food, that comes into play. And AI is only there to help rationalize maybe and help doing things. If you have not all the information at your disposal. So it's only a tiny part of that. If that goes wrong and you take a wrong decision, yeah, who is liable? I think it's the complete team should be liable, and also, but I think that I'm not a legal expert, but there's still a lot of discussion about that. So in the end, it will be also a medical device, what you are developing. And but the medical device regulation cannot deal with things that are only for 98% working right. That's very difficult to put that into the law. So people are thinking of that, how to circumvent that. But still, then machinery of Philips, Medtronic, or GE Healthcare, they also make mistakes. And there's an error rate which is declared at the beginning, and they are homologated by FDA or another entity. So it will be a continuing discussion, but it's something that we need to discuss with each other. It's very important. Yeah, I was asked in the beginning of Watson. Watson says you need to do this. The doctor decides something else, and the patient dies. Okay, what happens then? I don't know if he had chosen something differently. If the patient wouldn't have died, that's maybe there were circumstantial factors that we didn't take into account. So it's a very, very difficult discussion. Yeah.
I think this is a discussion that we can have for the coming 29 years. We're at the end of our time, so I want to thank you guys very much for all the very insightful answers that you gave. I thoroughly enjoyed this panel discussion, and it really makes me think that we should organize more of these, and definitely one with Marlies there as well, because she's of course the Ministry of
I know her well.
Information officer.
Marvelous things with the vaccination, the prullenbak vaccinatie.
Yeah, exactly.
Okay.
Thank you so much, Hildo, Nicky, and Smriti, and thank you for joining today. And I think we're going to go on to the closing of the event already. I think it's a beautiful conclusion, kind of something that Hildo said in the beginning already as well, that this is making it possible for us to kind of go more towards patient care, really, instead of doing all these boring technical tasks, right? Yes. And that's kind of the humanizing of healthcare, which is beautiful.
Yeah, very nice. Yeah. More time for the patient.
Yeah, exactly. All right. I think we're off already. So this is time for us to log off.
Okay.
Okay.
Take care.
Thank you.
Great
Bye bye.
meeting all of you. Bye.
All right, guys.
Bye.
Speak soon.
Bye.